Okay, so question 5. We've got a survey of 100 households gave the following results for weekly income as shown by the table. We're told that the sum of fy squared is given, and we're told that a histogram was drawn. Class interval 200 to 240 was represented by a rectangle of 2 and a height of 7. Calculate the width and height of the rectangle representing the class 320 to 400. Right, so the most important thing when we're dealing with histograms is to calculate the constant k, because the most important thing, well, one of the most important things about histograms is that the area of the bars are proportional to the frequency, which means that there is some relationship between the area and its frequency, and it's equal to k times f, where k is the constant of proportionality. So what we're going to do is work towards calculating this constant of proportionality. That's what we want to work out. So if I know that the width and the height of the rectangle we're asked to calculate. Well, we know the width of this class interval. Let's look at the class interval. This is the class width from 200 to 240, which is a class width of 40. So the class width is 40. The width is 2 and the height is 7, which means that its area must be 14. 2 times 7 is 14. It's going to equal k times by the frequency. Well, what is the frequency for that class interval from 200 to 240? We should be able to see 200 to 240. The frequency is 28. So k times 28, which means that solving for k is equal to a half. Now, that's the first part done. We need to work out k. We're asked to calculate the width and height of the rectangle 320 to 400. So let's consider that class width. The class width from 320 to 400 is a class width of 80. Now, if the class width is 80, that means that the bar width has to be twice the size of what this was. And I think the bar width in the last one was 2, which means that the bar width in this one must be 4. It must be double that. If the class width has doubled, then the bar width has doubled as well. So the bar width is 4. And we know that the area is going to equal k times f. The area is the width times by the height, and it's going to equal k times f. Let's substitute in what we know. The width is 4. The height we're going to work out. K is a half. We've calculated that. And the frequency for that particular class width, the frequency for the 320 to 400 region is 18. So that's 18. Let's solve for h now. So we get a half times 18 is 9, and then 9 divided by 4. So h equals 9 over 4, which is going to equal 2 and a quarter, 2.25 centimeters. That's the first part sorted. Let's have a look at what happens next. Use linear interpolation to estimate the median weekly income to the nearest pound. Okay, so the median value. Well, if there's 100 households, that means the median must be in the middle. So we're going to work out the cumulative frequency. We've got 12 and 28 is 30, 30 and 22 is 52, 52 and 18 is 70, 70 and 12 is 82, 82 and 8 is 90, which means I've done something wrong. Let me just double check that. 12 and 28 is not 30, it's 40. It is late in the evening, folks. Let's do that again. So we get 40, 62, 80, 92, and then 100. Okay, so where does the median value occur? Where do we get that median value? Well, I've got 40 at this point I got 62 here, so it happens in this class interval, in the third class interval. Now, so it's happening in here. How many of these do I need? Well, I'm not going to need 22 of them. I only need 10 of the 22. So I need 10 of this 22. So let's go down. Part B. I'm going to need 10 out of the 22 people. Now, what's the width of the bar? The width of this section, 10 out of 22. The width is from 240 to 320, which is 60, 70, 80. It's going to be 80. So 10 out of 22 multiplied by the class width, which is 80. And what we're going to do is we're going to add on the lowest bound. The lowest bound for this particular one is going to be 240 plus 240. So, out with the calculator. Let that do all the difficult work here. So you get 10 out of 22 times by 80. Close off the brackets. And we need to add on the lower bound, which is 240. It's going to give us an answer for the median of 276. I think it said to the nearest penny if I remember correctly, so 276.36. 276.36. Okay, let's check out the next part. Beg your pardon. Okay, estimate the mean and standard deviation of the weekly income for these data. All I've got is sum of fy squared. Great opportunity here to use the calculator. We need to make sure things are set up in the right mode. So I'm going to hit shift, set up. I'm going to check that my stat mode. I'm going to turn the frequency on. That's the first thing. Now we're going to go mode, statistics, single variable here. So I'm going to put in all the midpoints. So 100, 220, 280, 360, 500 and 700. And now let's put the frequencies in to match. So 12, 28, 22, 18, 12 again, and then 8. So we put in all the summary statistics. Let's just check that the sum of fy squared gives us this value. Make sure we put it in right. So hit shift, stat. We're looking at the sums, so 3, and I want the sum of fy squared, which is going to be the same as option 1 here. Hit the 1 equals 12452800. Absolutely brilliant. Okay, so I've got those. I'll also want the sum of x, so let's hit option 2. Sum of x is going to be 31600. So let's scroll down here. So for part C, sum of fy is going to be 31600. And I think we have enough now to work out the mean and the standard deviation. We should be able to go with that. Right, so yeah, let's go with the mean. So the mean y bar is going to equal sum of fy over the sum of f, which is 31600 over 100. I think there was 100 households, which is going to give us £316. I'm going to confirm that with the calculator, because that actually will tell me whether I've done it exactly right. Shift, stat, go to VAR, look for X bar, option 2, and we get 316. Brilliant. Now the next thing we're going to do is the standard deviation, sigma. That's going to equal the square root. And what I always say is the mean of the squares minus the square of the mean. So sum of fy to be squared over sum of f minus the square of the mean. That's sum of fy over sum of f to be squared. Let's plug in the values. So we're going to get the square root. I need to put in all these values. 12452800. 12452800. I wonder if they could have made that number any longer. Over 100 minus 31600 over 100 to be squared. Now we could type that all into the calculator. I'm not really all that bothered. I'm actually going to get the calculator to do all the work for me here. I'm going to hit shift, stat, var. Go for option number 3 here. 157.07. Okay, so that's the standard deviation. Right, next part. One measure of skewness is 3 times the mean minus the median over the standard deviation. Use this measure to calculate the skewness and describe its value. Okay. So, part D, we want to do 3 times the mean, which is 316, minus the median. The median, I think, was 276.36. 276.36. 3 times the mean minus the median, all over the standard deviation, 157.07. And let's get the calculator out. Okay, so 3 times 316 minus 276.36, and I need to divide that by 157.07. Going to give me 0.757. To 3 significant figures. 0.757. It's a positive number, which is telling me that it's a positive skew. So we got a positive skew. Okay, Katie suggests using the random variable x, which has a normal distribution with mean of 320, standard deviation of 150, to model the weekly income for these data. Find the probability that it's between 240 and 400. Okay, so let's start by drawing a little sketch of what's going on. So I'm going to draw my axes like so. It's normally distributed, so something like this. Not the best sketch in the world, but however. It tells us that the mean is 320 and that the standard deviation is 150, and we're also trying to work out the probability that it's between 240 and 400. So 400 and 240, like so. Okay, now just a normal distribution question. As always, we like to have a transformed one underneath. So I'm going to map this to the standard normal distribution, where the mean is 0. And essentially what I want to know is, what is the area of this section here? In fact, if I want to work out the area of this section here, one thing you might notice is that from 240 to 320 is actually the same distance as from 320 to 400. So that means that actually I could just work out the probability that x is less than 400, which would tell me everything to the left of 400. So I'm going to include this part. I could take away a half, which would remove this part and leave me with simply this region here. And then if I double my answer, I'm going to get both the blue and the green region. So I'm going to actually head towards working out the probability that x is less than 400. So what is this Z value here going to be? Well, Z equals X minus mu. X is 400. The mean we've worked out, or we're told, is 320 over the standard deviation, which is 150. So 150. Okay, out with the calculator. So we're going to get that should be 320. I'll change that in a moment. So 400 take away 320 is 80. 80 divided by 150 is going to give me 0.533. Not 0.533, and the 3 is recurring. That should have been a 320. Okay, so Z is 0.533. Now make a bit more space here. Okay, so the probability that the standard normal is less than 0.53 recurring, we're going to need our tables. 0.533, we need to go up a little bit. There we go, 0.7019. We can read it off from here, 0.7019. So that will tell me everything to the left of 400. So I've worked out all of this region here. Now what I'm going to do is take away 0.5, which is going to eliminate all of this and leave me with the blue. So 0.7019 take away 0.5 equals 0.2019, and then we're going to double my answer. So if I double this, it's going to give me what we were looking for. So 2 times 0.2019, 2 times 0.2019 is going to give me 0.4038. So the probability that X is between 240 and 400 is 0.4038. Okay, now the next part is to work out, with reference to your calculations in part D and E and the data in the table, comment on Katie's suggestion. Well, this is not a particularly bad value for this range, so it's a good fit for range 240 to 400, so for that range, but because it's skewed, we can't say it's a good fit overall. So because skewed, not good fit, running out of space here, overall. So it's not a good fit overall. It's pretty decent for this particular range here, but not a good fit overall. The reason why it's useful is because the mean we calculated earlier on was around about 316. Here it's 320, so it's a decent fit within this range, but overall not a good fit because of the skewness.